Hello, everyone. Thank you for inviting Alice and I to talk to you today about Jurassic Park and some of the myths and truths within the book and within the movie. We'll probably mostly be focusing on the myths more than the truths because that's a little more fun to talk about. But we hope you enjoyed the book. I had a huge influence on both of us deciding our careers and wanting to be research scientists. So it's big influence on us, and we're excited to talk to you about it today. To introduce myself, I'm Dave Grossnickel. I'm a researcher here at the University of Washington. My boss is a professor in the biology department and then also a curator at the Burke Museum of Natural History, which I'm showcasing behind me here in the background, which is a brand new building and a fantastic natural history museum. It has a collections of modern mammals that Alice and I both work on somewhat, and then also fossils, and a lot of fossils of mammals and dinosaurs and plants and all kinds of things housed within here. So later in the presentation, I'm going to show a couple more videos from within the museum. We decided to split up this presentation. The first half, I will be talking about kind of what it's really like to be a paleontologist and do paleontological field work, and then Allison will talk more on some of the myths, the specific myths or misconceptions within the book and the movie of Jurassic Park. So hope you enjoy this, and yeah, thank you again for inviting us.
So I'm going to start off by trying to tackle a question that was sent to us. The question is, were dinosaurs located all around the world or just certain locations? And to help answer that question, I pulled up a map from the Paleobiology database, which is an online website or online database that you can go to, and you can search for fossil occurrences, fossil localities, and different groups like dinosaurs. And so I've typed in Dinosauria, which is the fancy official name for dinosaurs, and then I filtered the search so just the Mesozoic era, which is the age of dinosaurs. And there's our timeline down here, and the Mesozoic is from about 250 million years ago to 66 million years ago. That's when the asteroid hit and knocked out a lot of the dinosaurs. And then we had the age of mammals and the Cenozoic after that. And the Mesozoic is made up of the Triassic and Jurassic and Cretaceous. So the Jurassic is where Jurassic Park gets its name. But there was actually a lot of dinosaurs in the Cretaceous that are in the movie Jurassic Park. So things like T-Rex was actually around right at when the asteroid hit 66 million years ago. So it's from the end of the Cretaceous, not actually the Jurassic. But anyway, so this is the Mesozoic era, and this is all the published fossil occurrences of dinosaurs. All these dots represent a fossil occurrence that has been published on and in scientific literature. And as you can see, there's just many occurrences all around the world. So the answer to the question is yes, dinosaurs were all over the place. They were on every continent. We see them even in Antarctica down here, which I'll talk about more in a minute. But you see a lot of them along like mountain ranges, like the Andes Mountains and the Rocky Mountains, and in the Alps, and that's partly because those rocks have uplifted during the mountain formations, and now they're exposed and they're eroding away, and we can find fossils there. So just because there's gaps like up in Siberia here where we don't see much fossils, doesn't mean that dinosaurs weren't there. It just means that we don't have rock exposed from the right time period when the dinosaurs were around. But most likely they were all over the place, all over the world. And one of the things I will highlight is this area right up in here where we find a lot of fossils right up against kind of the Rocky Mountains, and that's where a lot of paleontological work happens, and the work that I do happens. So I'm going to talk about that here more in a minute. So the world 66 million years ago was quite a bit different than what it is now. So this is what the kind of Earth looks like, and Antarctica wasn't snow-capped at the time. It would have had an environment more similar to the kind of the Midwest, probably temperate forest area. And so that's why we find dinosaurs even in Antarctica. And notice also Australia was attached, and some of these southern land masses were attached at one point, and that there was migration of dinosaurs from these major continents back tens of millions of years ago. To zoom in on North America, there used to be this seaway that kind of cut North America in half. And as sediment was coming down from the mountains, kind of the early Rocky Mountains that were forming to the west, the sediment was getting deposited along this shoreline. It'd kind of be similar to sediment coming down the Mississippi River, now filling in the Gulf of Mexico, or very slowly filling in the Gulf of Mexico. That was happening in Montana 70 million years ago. And that's where we now find a lot of fossils, because that sediment coming down from the rivers was burying things like bones from dinosaurs and mammals and different organisms. And those rock layers are now being exposed as they erode away. And those are the rock layers that we kind of see in a lot of badlands areas or outcrop areas out in western United States. And this includes that Missouri Breaks area, which is in Montana, but it's named Missouri because of the Missouri River cuts up into Montana, and it's eroded away some of the land there and exposed these kind of hillsides that we find fossil localities in. So specifically where I've done work and where that's pertinent to the Jurassic Park here, I'll get to here in a minute, is near Fort Peck Lake, which is the Missouri formed by a dam on the Missouri River. And it's this huge lake. It's something like 75 miles long, and it's this massive lake. But in that area is a lot of that exposed area like I just showed. Here's another picture. You can see a little bit of a kind of a finger off of the Fort Peck Reservoir back here in the background, but it's again a huge lake. A lot of the localities we go to, we can see a little bit of the reservoir, the Fort Peck Lake from somewhere. This is from a fossil locality up on a hillside that we're taking photographs from right here. And this area in Montana is famous for fossil localities because it captures the rock layers that were deposited at the time that the dinosaurs went extinct 66 million years ago. So it has these amazing rock layers where dinosaurs are preserved, other animals are preserved, plants are preserved, and it's from a really interesting time period. And so it brings in a lot of research groups, including ones I've been part of, and then also private fossil collectors come to that area and try to dig up fossils as well, and then sell those or donate those sometimes. So there's a lot of people out there every summer kind of looking around this area for and digging up fossils. So that was kind of the motivation for this scene in Jurassic Park. And this is supposed to be kind of that same area in Montana. They call it, I think, the Snake River area, but we call it the Hell Creek area of New York, or not New York, of Montana, because the rock formation that preserves these dinosaurs is called the Hell Creek Formation. But here is that scene, one of the scenes from the movie, which I can't. It's been a while since I've read the book. I don't know how they go into detail like this in the book. But as you can see, they're scraping away a dinosaur with brushes, and we do use brushes like that to kind of carefully brush away some sediment from the fossils. And you have eventually exposed this beautiful skeleton, entire skeleton of a dinosaur.
different shape too.
Okay, so I want to briefly talk about a few misconceptions from just that kind of 2-minute clip there. There's a lot of misconceptions there, a lot of issues that I have with that scene. First, that underground radar doesn't work. We don't actually use anything like that. Things like that have been tested, but the problem is, one of the big problems is that fossils are rocks, and they've been mineralized. The organic material of bone has been replaced by minerals. And so fossil is a type of rock. Fossils are a type of rock. So they're embedded in other rocks. So it's hard to distinguish the two types of rock, of fossil rock versus the sedimentary rock around it. And so it doesn't stand out nearly as much as like that scene shows. And then also to really have that, to be able to see bones like that, it has to be massive bones. Small little, finger bones or teeth or things like that just would not show up on a radar, underground radar like that. Okay, another misconception is that the skeletons aren't easy to uncover. Fossils are usually found in very hard rock, not loose sand like they show in that scene. So here's a video I took out in the field one year, and this is you can just kind of start to see it, and you'll see it better when I start the video. But this is the end of a femur, and so the femur is the thigh bone. This is of a hadrosaur, duck-billed dinosaur. They're pretty good size. This all right here is about 6 inches for scale. And oops, a second here. And this is the end of the femur that would be articulating with the tibia of the lower leg, basically forming the knee joint. And it's kind of sticking out of this really hard rock that we have to use. We have to use some tools, chisels and things to slowly chip away at and expose that bone. Something else that's a misconception, or kind of, I guess, misleading, I should say, from that video from Jurassic Park, or that scene from Jurassic Park, is that we don't find full skeletons like that, or extremely rare to find full skeletons like that. Most of the time, 99% of the time when we go out and look for fossils, we find little fragments of them, and then on a rare occasion we find maybe a full leg or a full skull or things, but very rarely, at least in the localities that I go to, we don't generally find a full skeleton. So here's the type of things that we typically find: little bits of, this is turtle shell, we find little toe bones, teeth, fish teeth and crocodile teeth, mammal teeth. These are all gar scale. A lot of these that look like little arrowheads are scales from gar, a type of fish. So that's a lot of what we find out in the field, not these beautiful full skeletons. Also, I think there's a misconception, maybe not promoted by that clip, but there's a misconception that all paleontologists focus on dinosaurs or study dinosaurs. But there are many people, including Allison and myself, who are more interested in mammals and mammal evolution. There's people like Ellie Sadler from the movie, who is more interested in plants. And so there's a lot of people that focus on different diverse groups. Dinosaurs are specifically reptiles, and people, again, like Alice and I, who studied mammals, a completely different group of organisms that we're looking at. We also aren't just trying to find new species of things like dinosaurs or mammals. We're also just trying to get data points for analyses. And so what I mean by that is, when we go out in the field, we often collect as much as we can, the turtle shells, the mammal teeth, shark teeth, gar scales, all these different things. We come back, it gets entered into databases, it gets put into collections in the museums, and then we can go through those collections and we can run statistical analyses on that. We can look at how many fossils of different organisms we find, different species we find at different rock layers. And there's all different types of questions that we can ask. I show kind of an example here of a study that was done based on all these mammal teeth that we find out in the Hell Creek region of Montana. So that's really what we're doing usually when we go out to fieldwork, is we're collecting what we consider collecting data points for our analyses. We're not trying to find some new exciting dinosaur, although of course that's exciting when that happens. So I want to show you a quick video here.
So I'm now in the fossil collections, the vertebrate fossil collection area at the Burke Museum. And as you can see, there's just kind of rows and rows of these drawers, cabinets. And these are packed full of different fossils from different time periods and rock formations, where curators and collection managers and different people who work here at the museum over the decades have gone and collected fossils and brought them back here, or fossils have been donated to us from other people or collectors or institutions. Some of those fossils, like you could see up on the shelves here, are big ones. Those are like the big dinosaurs that get the most attention. But as I've highlighted, we also find a lot of little things. So I'm gonna open up some drawers here just to kind of show you what we typically find. And again, we find just hundreds and thousands of fossils when we go out into the field. So here's just containers full of turtle shells. These are 70 million year old turtles, or bits of turtle shell that are just packed into these containers. These are little bits of Triceratops teeth, fragments of Triceratops teeth that have broken apart, and we can kind of tell by the enamel or the coloration and the texture there, and compare it to other full teeth and jaws of Triceratops, kind of figure that out. Other things down here, we got these are like crocodile backbones, or backbones from a crocodile-like creature, and then just drawers and drawers like this of material that we find. And so this just gives us a ton of fossils to work with if we wanted to come back here and study things like the Triceratops teeth or the crocodile backbones. We have this huge sample now, just filling up these cabinets here at the museum. Gives us a lot of data to work with. And also, while I'm here, I'll quickly shut this if I can, and just show you that this is a kind of one of the prep areas, workstations here, and then the exhibits are on the other side of this glass window, so the visitors can kind of come in here and watch people working. Here's some of the exhibits and dinosaurs on display out there. And then across the hall, it may be hard to see through the reflections, but we have some preparators that are cleaning fossils in a different room here, and also the public can come up here and watch them clean up the fossils, and things like the Tufts Love T-Rex skull was getting cleaned up in rooms like that for people to watch.
Okay, so I wanted to highlight again that most of the time when we go out and dig up fossils, we don't find dinosaurs, or if we do find dinosaurs, just little fragments, and we're focusing on collecting a lot of little things because they offer us data points for analyses. But of course, it's exciting when we do find a big dinosaur. And I just mentioned in that video that the Tufts Love T-Rex, and I kind of got ahead of myself there because I wanted to introduce that now, or talk about that T-Rex. And it's a skull that we discovered, or the Burke Museum's crew discovered several years ago, and I have a lot of photos from that. So I'm going to kind of walk you through the process of finding that skull and the process or basically the steps it takes to get that skull from the ground into the museum and on display. So two volunteers, Luke Tufts and Jason Love, hence the name Tufts Love T-Rex, found material like this while prospecting in about 2013. So a while ago now, about 8 years ago, and it has this kind of unique structure to it. Some of the material they found on the ground, and this honeycomb, like it's described as kind of honeycomb-like structure to this bone. And that's very specific to tyrannosaurs. Their bones, a lot of times, like T-Rex, have this honeycomb-like structure. So they made a note of it, and they took a GPS coordinates from the spot where they found this bone, and they gave it back to us and said, hey, you should come check this out sometime. So skip ahead a couple years. I know this isn't a very good photograph, but this is the only photograph I could find of when we were out in the field. That a couple years later, when we got a chance to go to this locality that Tufts and Love told us to check out. That's where we found the fossil bones. And so this is before we've kind of done any digging, and this was just that chunk of bone that's still kind of embedded in rock. It's just this really kind of nasty, just chunk of kind of broken up bone with that honeycomb texture, and it's down here on the ground. Again, just little chunks of bone, but there's also kind of rock building around it, or still around it. And then one of the guys on the crew started kind of scraping away at the hillside and uncovered this piece of bone right here, about a kind of a foot wide, foot tall piece of bone, and got excited. The reason is, and as I kind of go through this slideshow, every time I have this little red arrow, that's where we originally find part of the skull of this T-Rex right here. And so that's what I'm calling the original fossil discovery, is a red arrow in all of my pictures from here on out. And thought this looks like a bit of a T-Rex skull. But the problem is trying to figure out what part of a T-Rex skull this might be. Well, luckily, Dave DeMar, who was kind of head of the crew that went out that summer, has a tattoo of a T-Rex skull on his forearm. So he pulls out the tattoo, and we realize that it's this part of the skull, but it's upside down. It's an upside down skull, probably in the rock behind here. And again, figured that out by kind of turning Dave's forearm upside down to see what part of the skull that might have been. Next day or two, Jack Horner happened to be in the area. And Jack Horner is a famous paleontologist who has been digging up fossils in the area for 40 or 50 years, and he is partly famous, and he confirmed that he thought this was a T-Rex. This is me next to him looking at this, now it's kind of shaded, but the same spot in the hillside. He confirmed that he thought this was part of a T-Rex skull. And Jack Horner is partly famous because he was the dinosaur paleontological advisor on the Jurassic Park movies. So, at least the first couple movies, and here he is with Dr. Grant and others on the set. So yeah, he's right there. So it was exciting to see him out in the field and have him come visit us and check out this discovery once he again heard about it and kind of got wind of it, that we might have found a T-Rex skull, and he came out and again helped confirm that it was. Okay, so we now know we have part of a T-Rex skull, but we don't know if it's just a fragment of the T-Rex skull, like maybe this is all it is and we dig in and there's nothing more to go with it, or it could be the entire skull. So we got kind of two options here, and we're of course hoping for this. But most of the time when we're out there, like I mentioned before, we usually just find fragments or parts of bones, and so we're kind of skeptical, thinking maybe we just found a chunk of a T-Rex skull. Well, we dug in a little bit further to the left here, and right kind of where Dave's armpit is, I guess, we found a tooth. And this is right where you kind of expect a tooth to be if this is a full skull. And we knew this was a T-Rex tooth because it has these little serrated edges to it, just like a serrated knife. And that's common in a lot of carnivores. Multiple types of carnivores have evolved that trait, including some like saber-toothed cats and T-Rexes and things like that. And so we knew this was probably the tooth of from that skull. So that was really exciting to find that, and it gave us a clue that we probably have most or a full skull in the hillside here. So we got this T-Rex. We think we might have a skull in the hillside, and we also want to know kind of when this animal lived. Well, luckily we're in a locality where we climb up the hillside, and we can spot the rock layer, which is kind of a coal layer, darker layer, just because it was kind of it was swampy time when the asteroid hit, and that marks in the geological timescale in our rock record, this kind of coal layer at the top of the hill is the time period when the asteroid hit. And so we're just down the slope from that, 30 feet down the slope. And so the rock sediment, or the sediment was deposited on top of this T-Rex skull and built up, and then shortly thereafter, probably, well, shortly, still thousands of years later, but maybe tens or hundreds of thousands of years later, after this asteroid hit and knocked out the dinosaurs. So this T-Rex lived probably within 1 million years before the asteroid hit that knocked out most of the dinosaurs, and they went extinct. The only group, of course, that survived are birds, which are technically dinosaurs. Okay, so we found this T-Rex skull. Now what? Well, you want to just dig in and just start seeing the rest of see if we can find the rest of the skull, but we can't do that here because we have this big mound of rock on top of it. And so the first thing we actually had to do is, one, we jacketed this, which means we put a plaster jacket on that. So now it's a white spot in our hillside because we put some plaster to protect that bone. We also put plaster on some of the other fragmentary bone that we found at the base of the hill, that honeycomb-like bone. So that's now why all these kind of parts are white down here, because we have these plaster protective jackets on them. And it's very similar to like the cast that you would put on when you have a broken bone as a kid. That's kind of what we're putting on these bones down here to protect them. So we had to then dig away this whole 20 feet of rock above that where that skull might have been. So that's what we ended up spending a lot of time doing. And yeah, just for reference, here's that original honeycomb-like fragmentary T-Rex bones that we found at the base of the hill, and then here is that bit from the skull that is right here. And we're then spent a lot of time, weeks and weeks and weeks, digging away at the top of the hill here. You can see us with a short clip here of us just kind of chipping away, get picks and rocks, hammers, and jackhammers out there, and just slowly taking down that hillside. So there was actually 2 summers worth of quarrying and excavating just to expose that area of that skull, which is again at the base here of the hill. And eventually it looked like this. So this is now a photograph looking down at that. Here's that original piece of the skull that we exposed. Now we've taken down this entire kind of hillside and above it, and now we have this shape of a skull here. Something I want to point out is, notice you can't really see the skull. It's still rock. We purposely leave rock around the skull or around bones that we find, especially delicate bones or important bones like dinosaur skulls, because the rock helps protect it. When we transport this back to the museum, we're in Montana here, but our museum's in Seattle. We got to drive this thing 15 hours away, and we want it in bouncing around the truck bed, and we want it to be protected. And if we expose all the surface of the fossil out in the field, it's likely to expose it to weather and damage that way. We might accidentally chip some of the bone ourselves because we're using like these crude kind of chisels and rock hammers, and we might break the bones ourselves. We would rather just leave this rock on there that's been around this bone for 70 million years and protecting it for 70 million years. We'll just leave it on there, take that whole chunk back of hopefully this skull inside the rock, and we'll take that big chunk back to the museum lab, and they'll delicately prepare it and take away with the very delicate tools and air scribes and different things, slowly take away this material where they can do a much better job than we can in the field. So that's something that's very different than what Jurassic Park shows. They show just you take a brush and you scrape, you brush away the sand, and there's suddenly this fully exposed skeleton or bone from a dinosaur. That's not what happens out in the field. Eventually, as we expose where we think most of the skull is, we put jackets, the plaster jackets around here, plaster casts around the entire chunk of basically now boulder that's out in the field, and we also put these 2x4s around there to really help stabilize it and protect it for when we transport this back to Seattle. This made headlines, and so it made even CNN that this T-Rex skull was found, just because this is kind of rare to have this full T-Rex skull, or what we think is a full T-Rex skull at this point. And A lot of people thought this was me down here, and I had multiple friends on Facebook say, I saw your butt on CNN. It actually isn't me, it's a friend of mine, Brody's, but it was fun nonetheless to get a little attention. Okay, so there are actually two pieces of this. As we were digging down the slope here, we actually ran into another piece of bone here. We have this separate jacket here, so I'm going to first focus on this part right here. So we took this part back to Seattle in the Burke Museum, and they took off the plaster cast on the top of the cast and carefully kind of exposed the rock. And then, like I mentioned, they slowly kind of chisel away with air scribes and little picks, like dental picks, slowly just take away the rock around the bone and expose it. And eventually we got this amazing looking jaw, beautiful jaw with the even the kind of glossy T-Rex teeth, and again the serrated edges, and just this amazing lower jaw of a T-Rex. So it's really exciting. So that was one of the first parts that was exposed in the museum. And then this bigger piece, bigger chunk, this giant boulder, was a bit more of a pain to get back to the museum. And that took a little bit more work. We needed a backhoe to get it into a truck bed, and then had to transport that in a truck bed all the way back to 15-hour drive back to Seattle and deliver it at the Burke Museum and carefully put it into this kind of giant wheel like contraption that allowed the preparators to spin it around and to expose different parts of it to slowly prepare it and take away that rock from around the skull. And preparators worked on this for a year or two, I think it took, to fully expose the skull, and just very delicate work for again, months, years to expose this. And slowly expose more and more. They were on display. There's glass windows here in the background where visitors to the museum could come and watch the preparators kind of working on this skull. There were some interesting things that were exposed. There's a little bit of a swelling right here in his upper lip. It turns out that was an injury. Exostosis is what it's called. And so there's some kind of unique things that were discovered. A couple other injuries. There were some holes in the jaw that were discovered that might have been infections, things like that, that were slowly exposed in the skull. Makes it kind of more unique. You learn a little bit more about the life and the history of this specific individual. So here's most of that skull exposed. A bit of the other side of the jaw was a bit broken, and you can see part of it here. So not kind of nicely in place, but otherwise most of the skull cranium is in very good shape. Here's Dave DeMar, who was out there in the field. I showed you his picture early on with the tattoo, and here's him with the tattoo out in the field, and here's the kind of final product, the entire skull exposed and now on display at the Burke Museum, and here's him pointing to his tattoo again on his arm. So pretty cool to see that.
I'm now outside the collections room that I talked about a few minutes ago. And I just want to quickly highlight the fossil displays here at the Burke Museum. This is our paleontological display room, and the centerpiece of this room is the T-Rex skull that I've been talking about. And you can see some of the stuff, the pictures I've shown even are on display here. Size-wise, this is this skull is about 80% the size of Sue the T-Rex's skull. That's Sue at the Field Museum. So this is a little bit younger than maybe an older teenager or young adult in age when it died. But the skull itself is one of the best preserved skulls in the world. It's one of only 15 to 20 complete T-Rex skulls, or nearly complete T-Rex skulls known. And every bone of the skull was preserved, which is extremely, extremely rare. There's only a few T-Rex skulls in the world like that. So just a really special specimen, and something I'm excited to have been a part of.
So in summary, that little 2-minute clip that I showed you of Jurassic Park at the beginning, that kind kind of sets the stage of what it, tries to show you what it might be like working out in the field, paleontological field work. There's a lot of misconceptions, a lot of misleading things in that segment, and really the work that we do, they kind of are quickly exposing this entire skeleton with just brushes and just kind of leaning over it and exposing it with brushes, and this kind of sand nicely just brushes away. That's very different than what actually happens. We spend multiple summers to get something like a full skeleton or a full skull of a T-Rex. Might take multiple summers of digging out the rock around that skull. We don't expose the bone itself. We leave the rock around it so that then we can take it back, and professionals in the museum, preparators, can slowly expose it, and that can take months or years in itself. So this was probably a 4 or 5 year process for us to get that one skull completely out of the ground and then fully exposed and on display at the Burke Museum. And so very different than kind of the way they display it here in the movie Jurassic Park. Okay, now I am going to turn it over to Allison for the second part of this, where she's going to talk about some more specific myths of Jurassic Park.